Okay, this is question 5 of the key questions 3.3 review. This one here is a plane is travelling south at 910 kilometres per hour. So it's a vector there of 910 kilometres. And it's going to meet a headwind of 70 kilometres per hour. These are exaggerated arrows here. 70 kilometres per hour going due north. Now, a headwind means it's head on. So what's the overall velocity of the plane relative to the ground? So I think we can just calculate this quite quickly in our heads, that if you were to be ploughing south into a wind which is going 70 north, you would find that you are not travelling at 910 kilometres. You'll be short of that by 70 kilometres. So common sense would just be a quick addition. Because these are in cardinal directions, we can just subtract them. We don't need to do much with it. So the actual answer will be 910 minus 70. So we'd have an effective 840 kilometres per hour progress in the south direction. So that's A. B's asking us what happens instead if it's not head on, but it is side on. So once again, we are travelling south at 910 kilometres per hour, and we meet it's directed towards the east, the 70 kilometres per hour. So there's a 70 kilometre hour wind there. What would be the resultant velocity of my plane? Well, if your plane is travelling there, downward at south, and then it hits that, then you'll be swept sideways at that angle, and this will be your resultant velocity. So you'll be deviated from your path by that angle, and you would be having this final velocity here. So that's simply able to be done by Pythagoras' theorem. So the resultant velocity, let's do the magnitude, would equal 910 squared plus 70 squared. So 910 squared plus 70 squared, square root the answer. You'd be travelling effectively at 912.7 kilometres per hour. And your effective angle of deviation would be the tan. So tan of theta would equal 70 over 910. So that theta would give us shift tan of 70 over 910. So that's around about 4.4 degrees. Okay, so this resultant vector here would be approximately 913 kilometres, and you'd be deviated at 4 degrees. Okay, thank you.